Now we're going to go back to J.J. Thomson for just a little bit. Remember, J.J. Thomson was the man who discovered the electron and discovered that it had a negative charge. He also came up with the plum pudding model of the atom. Now, one of J.J. Thomson's students was named Ernest Rutherford, and Ernest Rutherford in this time was doing experiments with the model of the atom that J.J. Thomson came up with in his mind, thinking, okay, an atom is going to consist of a positively charged ball of goo. Within it are these negatively charged electrons, and all of his experiments were kind of based on this. But Ernest Rutherford decided that he was going to take this and experiment with it further and maybe even try to prove Thomson's model correct. And what he did was called the gold foil experiment. It's his most famous experiment. And in this experiment, and I'll explain more about the experiment later, but in this experiment, he discovered that Thomson's model, while accurate in the fact that there are electrons, there is no positively charged goo that these electrons are sitting in. Instead, he discovered that atoms had very, very, very small, very hard, dense centers. And these we will come to call the nucleus. And this center, this small, dense, hard center, has a positive charge. So Rutherford is really credited for pretty much discovering the nucleus and discovering that it had a positive charge. Now, how did he do this? He did something called the gold foil experiment. Him and his fellow lab workers and students all sat around in the dark, waiting for their eyes to adjust to the dark so they could perform this experiment. And what they did was they had an alpha particle emitter. Now, here's the symbol for an alpha particle. It's really just a helium ion. So it has 2 protons, 2 neutrons, and no electrons. And here's another way of writing it, a helium ion or an alpha particle. They had an alpha particle emitter, and it would emit these tiny, tiny little particles with a lot of energy. Now, they would fire these guys at a sheet of gold foil, a super, super thin, pounded thin sheet of gold foil that was only a few atoms thick, as thin as they could possibly get it. Now, alpha particles should go through, right? If Thomson's plum pudding model was correct, that these alpha particles should go right through the gold foil, right through that positively charged goo, and go right through to the other side. What they did is they put a detecting screen around the experiment, and this screen would detect the presence of the alpha particles hitting it. And that's why they had to sit in the dark in their lab so they could see the detecting screen, the little light from each alpha particle hitting that detecting screen. And what they found was not that the alpha particles went right through. Instead, that they changed their trajectory and angled off in different directions, and some of them even came and bounced back. This was blowing Rutherford's mind. He likened this to firing a gun at a piece of tissue paper, expecting it to go through like Thomson's model said, but instead this bullet comes right back and hits you. That's how surprised he was at this discovery that he made. And because of this, he was able to hypothesize that there had to be something that those alpha particles hit. Now here's a simulation of what Rutherford expected. Here's the plum pudding model of the atom, a really super close-up view. The red is the positive charge, the blue things are electrons, and all those things going through are alpha particles. This is what Rutherford expected. He expected all of those alpha particles would go right through, but instead what happened is those alpha particles hit something. That something was the nucleus. And not only was it something small, round, hard, and dense, but it had a positive charge. It actually deflected those positive helium ions. And remember when I wrote that helium ion symbol? It has a positive charge, so it would repel other positive charges, like, say, a positive nucleus.